All right, so next thing is to look at the design of the sample survey. When we design a sample survey, we need to follow the following steps as suggested. First of all, we need to obtain a comprehensive sample frame. Like we need to have a target population, then we have it target correctly, then we have a list of all the candidates, then we can randomly choose some of the candidate to be in our sample. Secondly, we need to decide which method to sample the data. Like I said, we follow a probability sampling, but under probability sampling, we have a few different choices, like the simple random sampling, totally randomly chosen, stratified random sampling. That means in the original population, we have a set of the formats already set, then they have a certain order. Then we can easily pick some of them as a group, as a strata. Then we can choose randomly within the stratum. Cluster sampling, again, the population is in some kind of orders, and then we look at them in different groups of clusters. Then we randomly choose the cluster. Then we have the entire cluster sampled. Systematic sampling, that means we choose the sample in a systematic way. Every 10th unit or every 5th unit from the population, then we choose the sample. Multi-stage sampling, let's see if we have enough time to go to that multi-stage sampling in this course. Otherwise, multi-stage would be a combination of any two of the sampling scheme that we said above. Next slide shows us a better way of trying to understand how the sample is being chosen. So let's say if we have a population, then we choose our candidate randomly. So let's say we have a list of all of the university students, then we just choose randomly from the UID. So this candidate may be chosen, and then this guy was chosen, and those guy was chosen randomly. We choose that until the number of sample the size reach our required sample size. Stratified random sampling, like I said, if we have a population and then we can easily divide them into different groups. So we have the green groups and then we have the yellow groups. So within each of the group, we call it stratum. Within each of the stratum, we randomly choose some candidates. So let's say within the green group, we chose 2. Within the blue group, we chose 3 as our sample. Cluster sampling would be, again, in the population, we have already have a good form of different clusters. So like a 3 in a group, right? And then we randomly choose the group. So we call that a cluster of 3, cluster of 3, cluster of 3. We randomly choose the cluster, and then we interview each of them within the cluster. Systematic sampling, that means we arrange all of the population in a sequence, and then we choose every 4th candidate. So this is the first. So let's say this is the first. So the first start would be a second one. So every 4th candidate would be chosen. So this is 1, 2, 3, 4th. 1, 2, 3, 4th. 1, 2, 3, 4th. So we choose the sample in a systematic way. Then there are pros and cons among different sampling schemes and different requirements. And at the end of the day, we look at the chosen samples, calculate the estimate that we obtain from them, and then to find or to compare the different errors or the, like we said, we calculate the variance of the estimate from the different sampling scheme. The one which yield the smallest variance would give us a more precise estimate to picture the population, to estimate the population estimate. So we would end up choosing that particular sampling scheme. I can give you a head up with the simple random sampling and a different sampling scheme. Let's say if we have a random population, so choosing a simple random sampling would be very convenient, very easy to assess. That means we can easily just have the list of university students. We can randomly pick their UID and then choose the sample. When we have the population that they are nicely grouped, for example, like this population, nicely grouped into the green color and the blue color, and then we know that within the group or within the stratum, they have similar characteristics. So let's say they're all green people, and within this stratum, they're all blue people. Then if that's the case, we would likely choose the stratified random sampling scheme. For example, if I like to calculate the average, and secondly, very importantly, between the strata, we want them to be quite different. So that would be a blue color, and that would be a blue color, and this is the green color. So between strata, they're quite different, but within stratum, they're very similar. So let's say if I like to estimate the average income of the household in different districts in Hong Kong. So let's say we can easily divide Hong Kong into 18 districts. And then I would know that within this district, the household income are more or less similar. So let's say because of the household income in, let's say, living in Wan Chai would be quite similar as compared to those living on the south side, let's say in Stanley, would be quite different from those living in Wan Chai. But those people living in the south side with the affordability would be quite similar within the district, same as Wan Chai. But between them, the affordability would be quite different. So we can easily say that if I'm looking for the estimated household income, stratified random sampling could be a good method. Whereas cluster sample, if I like to look at the, for example, for cluster sample, I would again easily divide the population into different groups, into different clusters. But within the cluster, I know they are quite different. They're quite different. But between cluster, they're quite similar. So in that case, I would choose this cluster sampling. Another example, I like to estimate the average age within the household for a particular estate, let's say. Okay, so I know that within the household, within the flats, they might have the parents and the kids, parents and the kid, parents and the kid. So it's more like very similar in different flats that if you go interviewing. So we know that within the age, within the household, they are quite different for the age because of the age difference between the parents and the kid, right? But within the cluster, they are quite different. But between cluster, they're very similar. In that case, if I like to estimate the average household age, then using cluster sampling would be a better method. So you can see the difference between choosing stratified random sampling or the cluster sampling. For systematic sampling, it's only usually for the it's very easy to choose the sample. For example, if you are asking an interviewer to interview the person who walked out of a particular supermarket during the day. So for the interviewer, it might have some kind of bias towards whom is going to be chosen to be in the sample. Very apparently, usually people they tend to interview those who look more friendly, right? So if that's the case, the interviewer will likely have a subjective bias in terms of choosing the interviewees. But if I choose to use a systematic sampling, I ask the interviewer every fifth shopper who came out of the supermarket, then you go and interview him or her. So he doesn't have his own subjective bias of choosing the interviewee, because he only counts the every fifth customer who came out of the supermarket. So that reduces the bias to that sample to be chosen. So multi-stage sampling would be, for example, if I like to look at cluster sampling, this is the first stage that I choose cluster 2 and cluster 4. And the second stage, that means I combine a simple random sampling within the cluster sampling. So within the second cluster, I randomly choose one candidate. Within the cluster 4th, I randomly choose one candidate. So that would be a combination of cluster and simple random sampling. Depending on our budget or our times, then using a multi-stage sampling sometimes will result in a better estimate. Then thirdly would be the number of sampling units. So again, depending on our bounds of error or tolerance level, then we can determine what is the sample size. Of course, the higher the sample size that we can afford, the more precise estimate we will obtain. But again, the cost of conducting sample survey is another concern, so we need to limit our number of sampling units. But we can calculate that depending on our requirement. And then the design of the questionnaire, again, in the example class, you will see a very comprehensive discussion on the questionnaire design. How we design the questionnaire is very important, especially how you put the order of the questions, or when we deal with some of the sensitive questions. Designing a questionnaire is an art, and you can usually get a better result if you can put the questionnaire in a right order, or you ask question skillfully. Execution of the getting sample data. So you can also decide when you conduct a sample survey, would you like to do a face-to-face interview, or you only have the limited resources to do a telephone interview, etc. Method of estimate population parameters. We will talk about how we calculate the estimate for all of the parameters, like the average, proportion, or the total.